Syllogism. In this chapter, we will study what is syllogism and learn how to solve problems related to it. The word syllogism is about referring to logic. Syllogism is an important section of logical reasoning and hence a working knowledge of its rule is required. Hence it can be expressed as science of thought as expressed in language. The questions based on syllogism can be solved by using Venn diagram and some rules devised with the help of analytical ability. There are two types of questions asked in this section: specified form of problems and mixed or jumbled form of problems. Before we get into solving the problems, let's understand some terminology which are used in syllogism. Proposition. It is also known as premises. It is a sentence that asserts that either a part of or the whole of one set of the objects which is identified by the subject term in the sentence expressing that sentence either is included in or is excluded from another set. There are three types of propositions. Categorical proposition. There is a relationship between the subject and the predicate without any condition. Example: all beams are logs, no rod is stick. Hypothetical proposition. There is a relationship between subject and predicate which is asserted conditionally. Example: if it rains, he will not come. If he comes, I will accompany him. Disjunctive proposition. In a disjunctive proposition, the assertion is of alteration. Example: either he is brave or he is strong. Either he is happy or he cannot take revenge. Parts of proposition. It consists of 4 parts. Quantifier. In quantifier, the words all, no, and some are used in the sentence and they are called so as they express quantity. All and no are universal quantifiers because they refer to every object in a certain set, while the quantifier some is a particular quantifier because it refers to at least one existing object in a certain set. Subject. It is the word about which something is said. Predicate. It is the part of the proposition which denotes which is affirmed or denied about the subject. Copula. It is the part of the proposition which denotes the relationship between the subject and the predicate. Here is an example. All boys are brilliant. Here, all is a quantifier, boys is a subject, are is a copula, and brilliant is the predicate. Hence, the standard form of proposition is quantifier plus subject plus copula plus predicate. Rules of deriving the conclusions from two given premises. Universal affirmative or A-type proposition. Take an example. All goats are dogs. This is A-type proposition. We can see it by the graphical representation of the above proposition. We observe that goats are distributed in dogs, hence we cannot conclude this in A-type proposition. Only subject is distributed. Universal negative or E-type proposition. Take an example. No girl is boy. In this type of proposition, both subject and predicate are in denial of each other. This can also be seen in the diagram representation boy and girl. They have nothing in common, hence both subject are predicate and distributed. Particular affirmative or I-type proposition. Take an example. Some mobiles are telephones. In this type of proposition, subject and predicate have something in common. This implies that in I-type, neither subject nor predicate is distributed. We can see it graphically as given in the figure. Particular negative or O-type proposition. Take an example. Some boys are not students. In O-type proposition, some of the category represented by boys subject is not students, which means that a section of boys is denied with the entire category of the students. It is therefore deduced that in O-type proposition, only predicate is distributed. On account of the different logical approach required to be applied, drawing each type of inference, a clear understanding of this difference becomes more important. Now let's go through some solved examples. Type 1. Specified form of problems. Question. The statements are: all mangoes are chairs, some chairs are tables. And the given conclusions are: all mangoes are tables, some tables are mangoes, and no mango is a table. Solution. In a Venn diagram representation, all possible cases can be shown. Here, the term chair is common to both the statements, and hence is a middle term. Statement 1 is A-type proposition, and in A-type proposition, only subject is distributed. Hence, chair being the predicate in sentence 1 is not distributed in the second statement. Thus, none of the conclusions following the statement is a valid inference. That is, in conclusion 1, all mangoes are tables. This inference is definitely false. Neither A nor B shows this conclusion. In conclusion 2, some tables are mangoes. This inference is uncertain or doubtful. And in conclusion 3, no mango is a table. This inference is also uncertain or doubtful. Therefore, it can be concluded from the above discussion that no valid inference can be drawn between mango and table. Type 2. Mixed or jumbled form of problems. In such type of problems, there is a constitution of mixed problems of universal and particular premises. Question. The statements are: some pictures are frames. Some frames are idols. All idols are curtains. And the conclusions are: some curtains are pictures, some curtains are frames, and some idols are frames. The Venn diagram shown on the screen is derived from the statements given in the question. Now let's compare them to the conclusions. Conclusion 1. Some curtains are pictures. Clearly, this does not follow. Conclusion 2. Some curtains are frame. From the Venn diagram, we can say that this follows. And conclusion 3. Some idols are frames. This follows as well. Hence, only conclusion 2 and conclusion 3 follow.